Let's see question number 3 of internal 1. How are polynomial represented in computer? Write an algorithm to evaluate polynomial. Px equal to an x to the power n plus an minus 1 x to the power n minus 1 plus dash 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 up to a1x plus an. Here are two subparts, so let's solve this. A polynomial p of x is an expression in variable x which is in the form of ax ki power n plus bx power n minus 1 plus up to ax plus a, where ax are the real number and n is the non-negative integer. N is called the degree of polynomial. Every term in polynomial consists of a degree and coefficient of n in the exponent. We will obtain an algorithm to evaluate the polynomial px equal to an x to the power n plus an minus 1 x to the power n minus 1 plus up to a1x plus a0. Evaluating this polynomial by a brute force technique is simple, but it will involve n plus 1 divided by 2 multiplication and addition. In this algorithm, which follows the number of multiplication is reduced to n. Thus, the algorithm is based on following alternative method of writing the equation, that is px equal to a0 plus a1x plus a2x square plus up to anxn, which is a0 plus x, a1 plus x, a2 plus dash 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 plus x, an minus 2 plus x, an minus 1 plus x, an minus 1. We will let this as equation number 1. Now let's see the algorithm. In step 1 we will read the value of x and n. In step 2 we will read use for loop for I equal to 0 to n in step 1 and 2 we will read aij, and then we will end our for loop. In step 4 we will assign n to p, and in step 5 we will start for loop where I equal to n to n in step of 1 do. In step 6 we will assign ai minus 1 plus xp to p. In step 7 we will write the value of p. In step 8 we will stop our algorithm. In the above algorithm, the for loop set up by instruction step 2 consists of only one statement, namely read a. This statement read the array a0, a0, an, which is used to store the coefficient of the polynomial. The for loop is set up by this has only one set instruction, which is divided by 6. The algorithm forces are one time in loop I and p, and from the given table you can see the above algorithm illustrates that in developing procedure for solving even simpler problem, a large amount of computation efforts may be saved by slight reformation of the problem. Let's see the B part of question number 3, which is write the recurrence relation of dividing the polynomial by x minus r. We will consider the problem of dividing the polynomial, which is an x to the power n plus an minus 1 x to the power n minus 1 plus up to a0 by x minus r. After dividing, if we call the reduced polynomial, which is bn minus 1 x to the power n minus 1 plus bn minus 2 x to the power n minus 2 plus up to b0, then equating the coefficient of the above polynomial with the quotient obtained by divisor above, we get bn minus 1 equal to an, bn minus 2 equal to an minus 1 plus ran, which is an minus 1 plus r bn minus 1, and bn minus 3 equal to an minus 2 plus r an minus 1 plus ran, which is an minus 2 plus r bn minus 2. So in general, bn minus I plus 1 equal to an minus I plus r bn minus I. Expressing of this recurrence relation through algorithm. So for in step 1 we will start for loop I equal to 0 to n in step 1 do, and then we will read ai, and then we will end our for loop. Then in step 2 we will assign an to bn minus 1. In step 3 we will again start our for loop for I equal to 0 to n minus 1 in step 1 do, and we will assign an minus 1 plus r bn minus I to bn minus I plus 1, and then we will end our for loop. In step 5 we will start our for loop for I equal to 0 to n minus 1 in step 1 do. In step 6 we will write the value of bi, and then we will end our for loop. In step 7 we will stop the algorithm. The above algorithm is very useful in reducing polynomial by removing the roots, and may be extended to case where the polynomial is to be divided by a quadratic factor. Thank you.